Hey, welcome back. I'm Pete Brown, developer evangelist at Microsoft, and I have with me here Chris Iverson.
Hi.
So what do you do?
I'm Chris Iverson. I'm a software developer at Microsoft, and I'm working on 3D printing. I've been on this team maybe 2 years, and we just recently moved to the Windows group because of the success we've had in the last period of time. So I'm very excited about that.
So I just talk about this stuff, and I'm an enthusiast user of this stuff, but you actually built some portion.
Yes, that's right. I worked on most of the SDK, the drivers for many of our hardware partners like MakerBot and 3D Systems, and I contribute a little bit on the application that I'll show you today. So I'm one of a small team of people, and I'm excited to show you what we've built.
Sweet. And you brought a bunch of toys.
Yeah.
But I thought maybe the first thing that we would do here is, I mean, there are going to be people who have no idea what a 3D printer is. So let's show them what the 3D printer is and show them the app that you've been working on.
Okay, great. So let me just start, and I'll just kind of show you this 3D printer I brought over here.
Okay.
If you can see this.
Can we switch to that camera? There we go.
So this is a TierTime Up Plus 2 printer. TierTime is a company in Beijing, China. They recently, just at CES, announced a native 3D print driver for the Windows print pipeline. This is I don't know the price on this particular print. I want to say it's about $1,200. It prints both in what's called PLA plastic and ABS plastic. You can see here, this is sort of the extruder, the place that the plastic is melted, and this is the material over here loaded on a reel. And as the printer lays down kind of level by level each part of the 3D design, you'll see the object build up and create the 3D print that you're intending. So I'd like to...
So PLA plastic,
yeah.
So there are two different types of plastics you mentioned. One is ABS, and that's kind of the same stuff a lot of toys are made out of, like high-quality toys are made out of.
That's correct. A lot of people in the industry like to call that Lego plastic. It's not from Lego, but it's the same material that they use in their durable parts.
Right.
PLA is a corn-based polymer that's very similar to some of the compostable silverware you get, like in
here.
Maybe the cafeteria here at Microsoft.
Here is the only place I've ever seen the stacks of compostable silverware.
Yeah.
So the PLA stuff, it tends not to peel up as much, and it doesn't require like a heated bed and other stuff.
Right.
So
yeah, ABS tends to be much more difficult to print with, but it also yields parts I find to be more usable for mechanical parts. Where PLA prints an excellent model, it's very easy for consumers, has a more pleasant smell too.
So before we show the demo app here for a second, so this is an example. Is this ABS or PLA?
I think that's PLA. I can tell just because of the shine on it.
So this is PLA plastic, and you won't be able to see here like the way it's done. But there are plenty of pictures of 3D printed models on the web here. But you'll be able to see that it's built up from different layers. It'll be one layer under another layer. So it's sort of an interesting sort of topographical construction where it's layer upon layer upon layer. And it's all being spit out, the technical term being extruded, right? Spit out of that printer.
Right.
That's not the only kind of printer, but that's the kind that we're going to focus on because it's
right. This is called additive manufacturing, is where you just put down the material that you need to do the print. The instructions that drive the printer are very similar to the instructions that were used on CNC machines, which is a form of subtractive manufacturing.
Meaning
different technology.
It cuts away as opposed to...
It cuts away, right, yeah, exactly. So this 3D printing tends to be dominated by this additive manufacturing technique. What's really cool about this model that we're looking at here is, it's an example of a trophy that you could like personalize in the software application. This has a number 2 on it. You could put maybe your son's name for a soccer game or something. So just a simple example.
If I'm going to print a trophy, it's not going to say 2 on it. If I'm going to print a trophy, it's got to be like
number 1.
Right? It's like I went through all the effort to come in number 2. No. That's not how it works. All right, but so you have an app here that you wanted to show us. So can we take a look at that?
Right, so Microsoft released an application called the 3D Builder. It's a very simple application that's used to show off sort of the integration with the Windows 8.1 print pipeline. So I'm going to launch that here. It comes with a catalog of objects. These are just look at this as a starting point for 3D printing. If you were to go buy your printer, you could just download this app from the Windows 8.1 App Store. You could pick an object. Let's just pick this train set here. I'm going to take the train. And you can see there's some assembly required on this particular model. What's neat about it, though, is it prints in one shot and you get a train that runs. I can show a sample of that in a second. So what I'm going to do here, you can see the basic kind of touch-first experience. It's just a standard kind of Windows 8.1 application. I'm going to print by using the devices print you see there's a 3D printer that shows up here. Now,
So that was just like when you want to print to a regular printer.
exactly the same code flow as if you were doing a 2D print job, which shows how easy this is to do. But notice the settings here aren't like, print in duplex. This is setting specific to a 3D printer. So there's quality, density, a few things that you might want to set to control the speed and the quality of the output. I'm going to hit print. And it does take a second. Unlike 2D printing that may start spitting out pages, the 3D printer needs to take this model, slice it into layers, and then create the instructions that then get sent over the wire to the 3D printer. Then the printer will warm up for a second and then do a kind of a dance that you'll see.
Now you have, in true sort of Betty Crocker style fashion, you have some things here that are already printed.
That's right.
From
yeah.
this. Can we take a look at one of those?
Sure,
models?
sure. I guess I'm going to start with my. This just shows that if you have a 3D printer, you have access to infinite gold and wealth. This is the key of Erebor. That was a promotional thing we did with the movie The Hobbit. So I've printed the key on this 3D printer right here with gold plastic, ABS plastic. So this just kind of shows you a fun thing you can do with the 3D printer. The movie is coming out. You can download the key, print it. My son had this around, carried this around for a couple of days. Thought it was just super cool, and it's very detailed. It's an excellent model.
And we did say this was the geek edition of the show. So actually, I heard the printer.
Oh yeah, the printer is over here.
Now it has to do some more stuff, right? It warmed up.
Yeah, it's going to home. It's going to find its locations, and then it's going to try to warm up the print head. So it's still not quite ready.
Yeah, I mean, the old laser printers. I'm old enough to remember back when the laser printers were a new thing. When they would take forever to warm up a lot of times too. So it's not all that unexpected. But this is, we won't capture really the level of detail here unless maybe we'll hold it up to that camera or something afterwards. But this is a very cool, and for the type of technology that we're looking at, for the way that it's printed, this is very detailed, right? So think like, oh cool, we have a savior coming over that we can, this camera, that camera? One of these cameras, there you go. Can you hold that up there? Let's see there. There we are. Excellent. So you can see there's a really high level of detail, and it came right from that printer that you're talking about.
Yes, that's right.
Behind it. So, and then now while you're there, can you show the train model that will be printed?
Okay, can you guys see over here? So this is just an example of a train set that came out of the 3D Builder application. This is the exact model that I'm working to print right now. The wheels were, of course, snapped on, but you can see there's some customization here. Again, there's like 0.8. I don't know if you can see that on the camera.
Yeah, red's always a hard color, right?
Yeah, there is some ability to kind of emboss this object with some text, or you put a letter on the side of it. Then there's a couple of different train cars and things, and then the track, of course, can all be printed very inexpensively. I also have a little present here. I thought since Valentine's Day was coming up, you could see an example of a 3D print. You could stick a little present in there maybe and give that to your loved one. Just some couple of ideas. Also, I've got...
oh yeah, we'll want to see that.
This is a model from Project Spark, which is another Microsoft game being developed by the Microsoft Game Studios. Project Spark is in beta right now. I don't know if you can see the detail on this, but this was done on this same printer that you see behind me. And very high resolution. This print probably took between 4 and 6 hours to do, with a lot of support material, which is needed to hold up those overhanging parts. But it's really cool. I mean, this is a pretty large print. Taking game content, digital content out of games and making them printables, just mind-blowing. Very cool idea.
Okay, cool. Thank you.
Yep.
And so we can see the 3D printer is printing a little bit there. We'll probably come back to a shot of that once it's laid down a couple of layers. But first, what I'd like to do is talk a little bit about the background. So 3D printing isn't new to everybody. There have been plenty of folks who have been able to use 3D printing from different operating systems for a while, and especially lots in Windows as well. But it was never part of the operating system. It was always something that was added on. Each manufacturer added on their own pieces, and there wasn't a centralized API. So 3D printing today, if we look at this, commercial and hobby are really the leading parts that are leading the innovation, right? So you have the large-scale printers that are commercial. They cost 5-digit type numbers usually in terms of what they run you. And then you have the hobby stuff, which is more. It's getting better, but it's like rep wrap, and they look like they're really, really fun, but they definitely look hobby. It's lots of looks like a bunch of rebar stuck together, but it's a bunch of threaded rod and stuff like that. Lots of upkeep and whatnot. And then we're starting to see more of the companies hit that sweet spot in the middle, where they're creating printers like the Up printer, like the MakerBot and other stuff, which still are priced, a bit more than let's just run to the store and buy one kind of impulse purchase, but they've been coming down significantly in price. So those printers are really just starting to edge into mainstream. My mother knew what 3D printing was. That's a pretty good bar in my mind of what what's hitting mainstream. If my mother asked me about 3D printing, then I'm like, okay, so obviously some folks have heard about it. Right? So where's it trending? It's definitely trending more towards mainstream consumer. I can definitely see a day where a 3D printer is as ubiquitous in the home as 2D printers were. It's kind of funny because 2D printers are like less people are having printers at their house these days because you don't have to print so much stuff out, but take that space and use it with a 3D printer. It's pretty good use of space there. So to give you an idea of sort of where the technology is, like you and I had discussed this before, 3D printing today is, it's where kind of expensive 2D printing was around 1984, I think is what you were saying.
That's right.
Printers were $2,500, just regular, plain old 2D printers are $2,500. Multicolor printing was not really, there. The resolution was pretty low. I had a dot matrix printer, loud as anything, low resolution, stuff like that. And even the very early laser printers had like 150 DPI, so it was very kind of chunky text. And so mostly only really dedicated enthusiasts and corporations had access. And one of the things that Microsoft did at the time is it worked with the 2D printer vendors, came up with the idea of a GDI printer, which a lot of people call the Win printer, where a lot of the logic was, offloaded from the printer, where these used to have like basically entire computers in the printer. They took that, offloaded that, put that into Windows, and then just established a protocol for how to get that data over to the printer. And what happened is that commoditized printing. Like printing took off. All of a sudden, everybody had laserjet, or not necessarily inkjet printers, and you could sell inkjet printers for less than the cost of the ink that was going in them, and you had that whole thing. So the idea of a $75 or a $99 printer was because of that offloading. So it required less stuff there. But it was also about having built-in support in the operating system for those types of printers. So by including that stuff inside Windows for 3D printing, we're doing the same kind of enabling for all those manufacturers that we did for 2D.
Yeah, I mean, in the end, it's the customer that wins in this because 3D printing has been very difficult tool chain with lots of software components. With integration in Windows now, it really is just like 2D printing, where you can load your 3D model and file print, and and you can see like the printer over here. The output just occur without a lot of post-processing.
Right. So the 2D printing pipeline, Word speaks to a standard 2D printing pipeline, and that goes out to a 2D printer. And for us, we're going to have a 3D printer that speaks to a standard 3D printing pipeline, which I believe is really part of the same pipeline. Is that correct? Yeah.
So I mean, this is actually built into the technical kind of services in Windows that runs 2D printing. So like things you're familiar with in 2D printing, like print queues. Or the printer view that shows what jobs are pending. All that stuff is the same with 3D printing.
Okay, so great. So I'm going to very quickly go through some of these, because you're going to show an actual example of some of the code here in a second.
Great.
So inside the app, you're going to invoke the device charm like you did earlier. You're going to choose the option to print. Then you're going to get that dialog. Now that dialog, or excuse me, that settings page, that printer settings page, is provided by the printer manufacturer. It's provided by us.
Yeah, really, actually, that's an interesting question. It depends on whether you're talking about a Windows Store application or a desktop application.
Okay.
In the case of a desktop application, that user experience is provided by the hardware manufacturer. In the case of a Windows Store application, Windows actually provides that.
Okay. So that's actually a really good point. This API is not something that's limited just to modern apps, Windows Store apps, right? It's also available on the desktop. So a WPF app could be written by somebody to, create a model or take an existing model and print it out through this 3D printing pipeline.
That's right.
Is that correct?
Yep.
Great. So 3D printing pipeline is extensible, right?
Yes.
So you can, hit it at different points. You can extend parts for, the mesh review and the fixing and the prepping and all the other types of steps that go through when you're preparing a model to be printed. We have lots of hooks in there that you can...
Yeah, that's right. I mean, some hardware manufacturers just use the samples that we have in our SDK, which we'll talk about in a few minutes. Other manufacturers will actually customize every module of that print driver. Like MakerBot, for example, has all custom code that they supplied for that. So it's very extensible.
Right. And here are just very specific steps. I'm not going to read this whole thing out to everybody here, but I want to make sure this was in the slide deck for folks that download this later. But if you're trying to understand the entire process here, it's very good to get an idea of how it works from front to back. So let's talk a little bit about how you interface with that 3D printer.
Okay.
So first you need to use a supported 3D printer.
Yeah.
Not every printer out there.
Yeah, I mean,
works
this is
that
early
way.
days for us, really, and if we just announced 3D printing support at Build last year in June. I had to, of course, wait for Windows 8.1 to get out. So, like, this is pretty early for us. We still, despite that, have most of the consumer printers available on the market supporting us now, like this TierTime printer behind me. The MakerBot Replicator 2, of course, is extremely popular, and the 3D Systems CubeTube printer driver as well. So all of these are the kinds of consumer printers I would expect you would be interested in purchasing.
Right.
And we're continuing to build out our driver samples to support hobbyists that are building their own printers. There's actually a very advanced sample in our SDK that will drive most of the RepRap style printers. That's not published as a plug and play driver right now, but it's an excellent starting point if you want to take a hobby printer and connect it to this pipeline.
So that's really good, right? Because RepRap printers kind of dominate the from scratch hobbyist landscape right now, and they're not just branded as RepRap. There are lots of things that use the underlying RepRap control boards and build upon that to create their own 3D printers. So it's good to know that we're interested in that community, and two, we're providing some samples that they can use, because clearly we can't provide support for every single one of those, because the reason why they're out there is because the hobbyists like to change the way that they function.
I have a RepRap printer I built, and of course I'm using the software with my printer. Again, this is not a final solution that we're providing the RepRap community, but if you take our SDK, you could take the code sample there and customize it for your printer, and it's an excellent starting point, and I hope to see that develop further in the future.
Great. So again, we said you need to use a supported 3D printer. Right, is the first thing. So we got that, and you can buy these at Staples, right? So you can buy. Is that the one you can get at Staples, or
no? This one is available online.
Okay, so that's online.
3D Systems printer is available in Staples.
Okay. MakerBot has their Replicator stuff, which we sell even in the Microsoft stores.
Yeah, Microsoft retail stores, I think across the United States at least, carries the Replicator 2, but you can also buy it on MakerBot's website as well.
And MakerBot just recently announced a whole new, something like 3 or so new printers. I think,
totally awesome. I mean, I love MakerBot's hardware. I have a MakerBot at home as well. Also, 3D Systems announced, I think, 5 printers at CES. So there's a whole kind of hardware refresh happening right now, and these printers are really exciting, super cool, and I hope to have all of them on supporting Windows soon.
Right. Okay. And so just as a point of discussion here for what this works on, it does work on the desktop, right? It does work for Windows Store apps, but it's Windows 8.1, right? It's not Windows. It's not the ARM-based Windows.
That's right. So this is if the question is would this work on a Surface, and it actually works on Surface Pro because Surface Pro allows extensible drivers. The ARM-based Surface doesn't allow extensible drivers now, but that's something I'd like to work on going forward. So maybe the next 6 months or year we'll have an ARM-based solution as well.
Yeah, that would be great.
Yeah.
So I would like to take this moment here and have you quickly go through the demo you have, because you have some source code. You can show some folks like what that API and what that code looks like. So let's switch over to your machine here.
Okay, great. So this is the first time we're going to try this on this machine. So what I have is a project, a Visual Studio project. It's a sample in our SDK that I've got loaded up. It's very similar to the 3D Builder app. It is a desktop application. It's a little simpler. I'm going to try to run this thing and set a couple of breakpoints in here. So let me first see if I can find my breakpoint.
So is this a C++ app?
This is a C++ app. Uses DirectX for UI. Sorry to...
No worries at all. There's a mouse over here if that's easier. We're trying out touch on these screens. These are not the best touch screens, as you've noticed. They have a target area about the size of your fist for any... Yeah. All right, so C++ app, is this an MVC app, or is this, excuse me, not MVC, MFC?
It's not using MFC, no.
Okay.
So I can't seem to find my file for some reason here.
There we go.
Print, control.
Yeah, there's quite a bit of code on here. H results, I don't see those very often.
Yeah.
Let's do this while you're navigating that. What's the... So the 3D printer I see has got probably a couple of layers down. Can we show that for just a second? So it looks like it's, 2 layers down? So you see it's starting to form the wheels on there. And you see you've got the bottom of the train engine. So, oh, hey, even better. Very cool. So what's interesting there is you can see what's called the infill, where you'll see the sort of diagonal hash inside where, you know, the model isn't necessarily printed solid because you can control that, like in the settings and the print dialogues and stuff. You can decide that to save material and save weight, that you can print the inside in sort of like a hashed or honeycomb.
Yeah, you can pick that. Yeah, usually the object quality determines that. Yeah.
Yeah.
So, yeah, I'm ready over here if you want to switch
good.
cameras. So here I've got this desktop app. It's called 3D Viewer. Again, it's very similar to the 3D Builder app, desktop app. I'm going to click Print, and you'll see, first of all, a breakpoint goes off in an Enum Printers API. This is the standard Windows Enum Printers API you would use for 2D printers. I just wanted to highlight that there is a flag up just above the screen where you can't see. Oops. Let me scroll down a little bit. Right here, there's a new flag called Printer Enum Category 3D. This is what tells the API to give me back the 3D printers on the machine, and and not include the 2D printers. So when you see that print view, you notice there isn't like XPS Writer or 2D printers. It's just the
3D printers are just another category of printer to Windows.
That's
at that
right.
point.
That's right. And then here you see the settings that the hardware manufacturers provide. So there's a very large number of interesting things for support material. I'm just going to hit OK and hopefully hit this breakpoint that I was looking for and kind of walk through the code here. This is basically the implementation of the print API in my application. I'm just going to show you quickly the APIs you would see. So the first part is just getting what's called a package target. These are just the interfaces with Windows you need to interact with the print system. This is exactly the same as if you were doing 2D printing.
Okay.
So up until this call down here where I'm actually going to query interface to get what's called the, well, it's a very long name, but it's the Open XPS with 3D flag. You can see it right here.
Yeah.
This will return to me the package writer targeted to the 3D printer.
Okay.
Now this is where this is the interface is different in the sense that you will provide a model file and a print ticket and that sort of thing. So I'm
sorry, the IDE font size is a little small, but we figured C++ guys could handle that, right?
Yeah, okay, sorry about that. And then we're going to get the interface to the object model. For the XPS object model, we'll create some parts in here that are required to write to 3D. And here you'll see, this is the 3D model part. I'm going to take my model stream, which is an application variable that I've set up. And you can, if you wanted to, you can download the sample and see how this model stream is filled in. But it's basically an XML stream of content defining the triangles and vertices for this model. Okay. Now I'm going to stream it into this package writer that I created earlier.
So we have an XPS, so if I understood this correctly, we have an XPS package, if you will.
Yeah.
XPS came out around the same time as like WPF.
Yeah, it's not exact. We're not using XPS like we do in 2D printing. We're basically using the what's called OPC container, and we're filling that with things that are OPC standard based to represent 3D content. Because XPS is very specific to 2D printing. We're not taking advantage of that stuff.
So if somebody starts looking through the Win32 API for anything related to 3D printing, they're not necessarily going to find that. They need to know, use the 2D printing APIs, use the same types of packages that we're doing before.
Yeah, we're basically using the object model, but yeah, we're filling it with different content. Yes. That's right. So, and then, so here I'm actually writing that stream into the part. In addition to the 3D model data, you also need to supply the print ticket, which is that settings I showed you just a second ago. That will get written in again as a XML. Actually, that print ticket is a specific stream that Windows sets up. And then you got to make sure you close this package writer before it gets committed to the print system. And that's it. That's all it takes to take an application and submit a model to a 3D printer. Now, at that point, it's going to now take the print job and send it to the print queue. Now, of course, if my printer's running, so that's another interesting feature here is that it will queue up print jobs. So you can print many things, and then as you clear the print job and say, I'm ready for the next print job, it will automatically start. So
okay. So this was a desktop app, right? Now, when you wrote the 3D printing Windows Store app, did you call the same type of Win32 APIs?
Yeah, the APIs are very similar. There is a slight difference in the way you get that initial interface, which is documented in our SDK. I don't have that sample available right this second, but it's basically the same thing.
Okay, but there is an SDK that you can use to get you started because, I'm generally a .NET programmer, and if I look at this stuff, I'm like, there's H results all over the place, and I'm not scared of it, but I'm like, all right, that's not super friendly to me.
Right.
But so there is a place to start off from the SDK that you can use for WinRT apps to be able to access this.
Yeah, there is a sample right now in the Windows SDK published. It's a very simple application. Again, it's C++. That's available on the internet right now.
Okay.
We have extensive samples for the driver and for applications like this app that I demoed today in our 3D printing SDK, and that's available through an email address that we'll provide you in a second.
Okay. So, kind of to wrap this up, I wanted to talk a little bit about how you go and sign up for that.
Okay.
So first of all, the main landing page at Microsoft for 3D printing is microsoft.com/3D.
Yep, that's right.
I don't know how you managed to land such a great URL, but congratulations, because that's /3D. That, I'm sure you were not the only one competing for that. And then I've just got a little bit.ly link here that has some video and details. I actually think it's a video that you did prior to Build.
That's probably the Build conference,
Yes, that has that. And then there's an alias here that you can email. It's ask3dprint@microsoft.com.
Yes.
And that's if, what kind of email do you want to get?
I mean, basically, anyone who's interested in our 3D printing SDK or has questions, technical questions, that email alias, actually, I'm on that, and so are a bunch of my colleagues. We look at that pretty much every day, and we get tons of requests. So we read every mail that comes through, and we try to help connect to the right content. In many cases, that is how you get access to our SDK download link. But technical questions, anything's fair game.
Right, and you've been refining the process and everything since Build happened. So
Yep.
I believe you've learned some things about the way customers work, and you've also just from working with so many different customers on here, you've modified your process a bit as well.
Yeah.
So it's slightly different from what you had to Build, but it still starts off with Ask 3D Print at Microsoft.
Yeah, we'd obviously like to make this stuff available via just download, but it's going to take some time to get there.
Yeah. Now because there's some licensing and some other things.
This is all available under a free license through Microsoft. The license pretty much requires that the 3MF spec stays on Windows, and I think that's the only requirement we have right now. So,
which I think would be a fair compromise,
Yeah.
since we've got the API there. So,
That's right.
So if you're interested in 3D printing, either as an app developer, as somebody who's just generally interested in kind of what our direction is on that, or if you are a developer of one of the devices, a 3D printing device, even if it's something that you created yourself in your basement, like so many of the RepRap ones and other things are, we definitely encourage you to email the Ask 3D Print alias with your questions on that, and see what we're going to support. Now, you're generally, you can't talk about future supported printers.
Right.
But you can say, if somebody says, "Is this printer supported?" You can say yes or no.
Yes, of course.
But we can't talk about future work, because we're working with partners on that, and
That's right.
entirely up to
Yeah,
them.
that's right. Uh-huh.
So great. So this is really exciting for me. I've got 2 3D printers coming
Okay.
next year. Neither one is currently supported by this, but I know we're reaching out to some of those vendors to see what they think about interfacing with this. But definitely over the next several years, I'm excited to see this really grow, because we are at the early stages right
That's right.
now. But if you're interested in making things at all, this is really a great set of APIs to do it.
Yeah, I guess my final kind of comment would be, if you're a student or an engineer or somebody who works on 3D designs and models, the 3D printer has become sort of the indispensable tool that you need if you want to go land that next cutting edge job. So this is an excellent time to get into 3D printing, and the software that we've developed and that I've showed here, I think, makes it really accessible and easy. So this is the time. Go check out your options and buy one.
Great. So before we wrap, can we get one last look at full screen on the 3D printer there? Let's see. You see it's put together a couple of layers. And the amount of time it takes is going to depend on the printer and the complexity and the detail level and what you're doing. We might let this run for a little bit, or we might just shut it off here in a second. Depends how much the noise drives everybody crazy. But I did want to thank you all for attending this here. And I especially want to thank you, Chris, for coming over and
thanks for
taking
having
some
me.
time.
Yeah, it's super fun.
Because we're not actually on campus. We're in downtown Redmond in the studio, so you had to get on in a car of some sort and help us by bringing all this stuff over and all the great equipment and the models and everything. So definitely thank you very much for taking the time on that.
Great, thanks for having me.
Thank you.